Hello, Year 12s. One of you asked me to go through this question, so let's go through it. So we have y is equal to 3 sine theta over 2 sine theta plus 2 cos theta. It's looking like it's a quotient rule differentiation. So let's start off. So this is equal to f of theta over g of theta. Sorry, my pen is being a bit silly. And then we do what we do. F of theta is equal to 3 sine theta. G of theta is equal to 2 sine theta plus 2 cos theta. And now let's differentiate both of these and see what we get. So f dash theta, 3 sine theta differentiated is just 3 cos theta. And g dash theta, again, that's quite simple differentiation. So 2 cos theta take away 2 sine theta. Remember, when we differentiate cos, we get a negative sign. Okay, so we cross multiply, but remember in the quotient rule, when we want to find dy d theta, we start with the one with the g theta first, to the differential of f dash theta first. So g theta times f dash theta take away f of theta times g dash theta all over g theta squared. G of theta squared. So let's plug all these things into the formula. So g of theta is 2 sine theta plus 2 cos theta. Multiply by f of theta, which is 3 cos theta. Take away f of theta, which is 3 sine theta. Multiply by g dash theta, which is 2 cos theta. Take away 2 sine theta. All over g of theta squared. So I'm not sure if you guys noticed, but I think already I can see stuff that can cancel out nicely. But let's continue with the question. So we definitely don't want to keep it in this form, especially since they tell us dy d theta is equal to a over 1 plus sine 2 theta, and we need to find what a is. So let's multiply things out and see if anything nice happens. So 3 cos theta times 3 sine theta is 6 sine theta cos theta. Cos theta plus 6 cos squared theta. Take away 3 sine theta times, so that's 6 sine theta cos theta. I just noticing now that I forgot the squared, but plus 6 sine squared theta. Okay, and now we divide the whole thing by the bottom bracket expanded. So that's double this bracket. So let's see, we have 4 sine theta squared plus 2 times 2 times 2 is 8. So 8 sine theta cos theta plus 4 cos squared theta. So what we did there is just expanded the bracket because since it's squared, it's double bracket. So now let's rearrange and see if anything nice happens. 6 sine theta cos theta in the numerator, it's subtracted, it cancels itself out. So since we have one of them is positive, one of them is negative, we can cancel this one out with this one. And then, if you notice on the new denominator, we gotta change color. We have 6 cos squared theta plus 6 sine squared theta. Ooh, that's interesting. We'll come back to that in a second, because I'm thinking in the numerator we're going to have a similar thing. So 4 sine squared theta plus 4 cos squared theta plus 8. So I'm just rearranging the numerator so we can notice something nice. We get that. Yeah, so you guys probably notice now we have 6. If we factorize out the 6, we have 6 bracket cos squared plus sine squared, and we know what cos squared plus sine squared is. And same with the numerator, we have 4 bracket sine squared. Sorry, I'm not writing the theta because yeah, cos squared plus sine squared we know is 1. Okay, that makes our life a little bit easier. Maybe we can just finish off the question a little bit easier. So now in the numerator we're just going to have 6, so since it's 6 times 1, and in the numerator we're going to have 4 plus 8 sine theta cos theta. Okay, this part here might not be as obvious to notice, but if you refresh your memory a little bit, if I'm not mistaken, sine 2a from our double angle identities we did earlier in the year is equal to 2 cos a sine a. Might be wrong, but I'm pretty sure that's the expansion. And here we can notice that we have a sine theta cos theta, and we're multiplying by 8. So if we wanted to go in reverse, for example, in this side, if I multiply both sides by 4, so 4 sine 2a is equal to 8 cos a. Sine a. Why is that a theta? That's meant to be an a. Yeah, so we can replace the 8 sine theta cos theta with 4 sine 2a. So that's equal to 6 over 4 plus 4 sine 2 theta. Let's check let's check what they give us initially. Okay, that's not exactly what we want, but I think we can do some rearranging to make it what we want. So we're looking for a, where a is a rational number. A rational number means it can be a it can be a fraction. So what I'm thinking is we can factorize out the 4 from the denominator. So 4 bracket 1 plus sine 2 theta. And now I know I tell you guys we don't like this and we don't want to see this, but let's divide top and bottom by 2 for now. But I think we're going to have to leave our answer as a fraction within a fraction, because that's what they want. So we have 3 over 2, 1 plus sine 2 theta. And then the final answer will be 3 over 2 all over 1 plus sine 2 theta. And I think that's the end of the... Yeah. All of this can be found on Miro. So if you have the same link we did before on Miro, and I'll check the mark scheme to see if the answer is right, but I think it is. And if you have any questions, do ask. Like the person who asked this question asked a couple of days ago. I only got time to answer it now. I'm with family in Dublin, so I will answer, but it might not be immediate. So please do ask, and I'm more than happy to answer.